podcast and YouTube blog covering the German startup scene with news, interviews, and live events.
Hello and welcome everybody. This is Joe from Startuprad.io, your startup podcast and YouTube blog from Germany, bringing you again an interview with a startup from Germany. This time we're going really deep check. I do have Tobias here with LUBIS EDA or LUBIS EDA from Cape Town, known to the Americans who've been stationed there for the Germans known as Kaiserslautern. And they are a startup who helps semiconductor producers to be faster and cheaper on the market. But first, let me introduce you to Tobias. Hey, how you doing?
Hey, I'm doing good. Thank you very much for the invite.
You are very welcome. Tell us a little bit about you. As always, people can reach out directly to you. Down here in the show notes, there's your LinkedIn profile. So what do people read there and what do people don't read there? What somebody does need to know about you besides you being a smart guy with a PhD?
Yeah, my LinkedIn profile is quite clean, I guess. Maybe that's a German habit to provide not too much information to social media. But I guess some things people don't know about me is that I'm working in software development since I'm 14. I started actually as a web designer. When I was a kid, I got like a small book, was just HTML, and then I made my way through to PHP, MySQL, and all like everything that's related to web. During my studies, I was working part-time as a software developer, kind of like a consulting-based thing, where companies hired me to develop software. So I was basically always programming and working in the domain of software. And I'm a software engineer at heart. Now comes the twist. I did actually plan after my studies to go to industry, what most engineers do some project management job. I was also working with a professor from TU Kaiserslautern. I also developed software for them. And I went to Michigan State to do my master's for an exchange program. So I was 1 year in Michigan. It's very nice there in case you're from there. I like your state. It's a nice one. But when I came back...
one question, have you been there in winter and did you need a lot of warm socks?
Oh, no. Actually, I kind of missed the winter a little bit, so I didn't stay for a full year, just 9 months. So I came just when the snow disappeared. I could just see some piles of snow lying around, and I left sometime November. So there was some snow, but I think I missed the really crazy, really cold Michigan winter. But the fall was just beautiful.
So no riding of snowmobiles there?
Unfortunately not, no. But I had a lot of fun with the mosquitoes in the summer at the lakes.
Awesome. Big metal high five to Michigan. Okay, you've been there, then you came back. And what did you do then?
When I came back, the professor already knew me from my work as a research assistant. And he asked me if I would be interested in pursuing a PhD. So I gave it some thought and I had a really good feeling about the professor. I think he's a great guy and I think he could really support me. And I decided to go for a PhD. However, the PhD was in the field of hardware. So semiconductor engineering, so to say. Technically, I have a PhD in computer engineering. And I was looking through what everyone is doing at the chair, because of course you can kind of find your own topic, but you also have to connect with what other people are doing at the chair. You cannot just come up with something that's not related to what the chair is doing. And I found one guy, he was working on a new methodology for hardware design. And I kind of looked at it and I was like, what he's doing is kind of similar to what people are doing in the software world a lot. So when I was programming, I used an agile programming methodology called test-driven development. In case you don't know it, the core idea is that before you write any features of your software, you write all the tests for the software. So once you implemented the feature, you know that the feature works correctly. And that methodology basically kicked off early 2000, and now I think most software is developed in that way, more or less. And I saw what he's doing, that you could apply the same idea to the domain of hardware, because hardware is mostly developed as software back in the day. So you have like these V-shaped waterfall models where you plan exactly everything ahead, but in the end nothing works. So I could see that switching to this kind of methodology could actually help the hardware world. So my research was mostly focused on the one hand side writing a software that generates something, and on the other hand side translate the idea of tests to the domain of hardware. And there's something very similar that transports the data very well, which is called formal property checking. I don't want to go into any details, but in the end, it gives you a clear yes or no answer, similar to tests and software, whether something works correctly or not. And I wrote a tool that generates you all the tests you need for your hardware development. And that's also the basis of our smart IP generation today that my company is selling.
So basically your PhD thesis gave you this idea, and what you guys are actually doing, can you really dumb this down for us, Barney style, and explain it like you would explain it to a little child or a business student?
Yeah. To a business student. Okay.
That's a real challenge, right?
So to dump it down, you can split the development of a semiconductor or microchip roughly in 3 phases. There's a specification phase, where you basically just write informal sheets. It's like just writing down the requirements and really specifying what the chip should do. And then based on that specification, you create something that's called a design. A design is basically source code, that it's a digital model that specifies how the transistors are connected, just on a digital model. And then in the third phase, you produce, based on that design description, the actual semiconductor. Now the problem, and this is interesting for the business people, the business students, is if you make a mistake in your design, and you have a problem in there, and you produce the chips, and you realize that the problem is there after you produce the chips, all the produced chips can go straight to waste. And we have to be aware that producing these chips is crazy expensive, because getting from a step from the digital model to basically have a production of the chip, that step costs a lot of money, because you need to create something that's called a mask, and creating this mask is really, really expensive. And what we can do is we can ensure that whatever you chip to the production is correct. So you don't have the risk of having to throw away all your produced chips, because we can guarantee that there's no bugs and no problems in your produced chips. So first of all, you save, of course, all the labor that goes into creating the design. But also, that's even more important for the entire industry, is that the earlier you get to market, the higher your profit margin is, because usually companies are waiting for you to get the chips ready. And whoever company gets the chips done first gets almost all the profit. So if you come late to market, your profit really shrinks to a bare minimum. So yes, you save the cost of labor, but you also gain the time to market benefit over your competitors by using our solution.
In your personal experience, what would be the time advantage? Say cutting down from 3 months to 3 days, or how could a semiconductor producer imagine this here?
Conservative estimation is 10% savings of time. But if you're really fast and you really have experience with our tool and our generation, I think you can save up to 20% in time. This is considering that the creation of the design takes about 30 weeks. So this is between a month and 2 months of time savings. And that may not sound that much, but sometimes it happens. Something that's the worst case for every semiconductor company is something called a respin. So before you hand over your design to the production, you will still run a last big test on your design. And if you find a bug, then you go back all the way and you have to go through all the 30 weeks again. And that may happen several times. So, tape out time can actually accumulate if you're really doing a poor job in your design. So with us, you only go through it once, you're even faster, and there's no need for respin, because we can guarantee that there will be no bugs in the design.
Whew, that is pretty cool. And how do you guys actually do this? You have some magic dust that goes over the hardware, and then it all works out fine?
So we do 2 different things. So first of all, we can generate a design. So you can start with a graphical user interface, and you can kind of design your what you want to do in a graphical means, and then you can push button, generate a design. That works for simple and easy designs, but usually every or most semiconductor companies have like some niche they're really good at. For example, some companies are really, really good at manually writing really power efficient design, or other companies are really good at writing really performant designs that just can crunch a lot of data. So for them, like a general IP generation doesn't really help them. So we can do something else, and that relates to what I talked about earlier, the test-driven development approach. We can generate them something that we call a verification IP. And if I talk about IP, it's not a pattern or something legal. It just means it's a digital component you can use. It's source code, basically. So we can generate this verification IP, and they can use that to verify whatever you implement in your design. And it's really quick because it uses a different technique than it is used today in the industry. And nobody's using this technique until now because it requires some expert knowledge to create this verification IP. But we can just automatically generate it so everybody can use this improved technique and get done faster with the process.
That already sounds pretty magic. Can you give us some idea? You said certain knowledge. So if now an executive of a semiconductor company listens to this audio podcast or watches the YouTube video, the question is right now, what would they need to change in their processes in order to be faster and almost error-free?
Yeah. If you listen to me and you're a CEO of a big company, you don't need to change that much. All you need to do is, instead of getting your verification team on board when the design is partly done, you will get it on board right away when the design process starts. So as soon as the first line of RTL code is done, you will have your verification IP in place. So the design verification team actually would start ahead of the designers and specifies what the designer should do. And the designer can focus on his main task of writing really efficient and really good designs. That's the only thing that will change. And of course, you will need our tool to generate the verification IP. That's of course, mandatory in this case.
Mm-hmm. That sounds pretty magic. Basically, you don't need to change a lot of your process. You're faster, and you also minimize the potential errors. Does already customer work with your product, or are you in a beta phase?
No, I think we are you could call us, we're in the seed phase. Right now we have 2 co-innovation projects running with customers. They're really interested in our tool, but of course, the first couple of tries with customers, we cannot really say that our tool is perfect yet. It's a good beta phase. So what we will do mostly now, we use it in-house, but also the customer uses it, and we do some projects together. We kind of have the role of a little bit of a consulting and a software company, and we run in parallel with the customers through the project and show them how it works. And if they have questions or if there's a bug in the tool, we fix it right away. This is our current state. I think coming next year, early next year, we should have a shippable version ready that you can just use out of the box with a day of consulting.
We are there talking right now. We have to tell our audience that we're recording this towards the end of August, but it will only be published in fall. And when you're talking about that, we talk about first quarter 2022.
Yes, exactly.
Mm-hmm. And basically, then people can go to your website and reach out to you. One question: when you've been telling us that you're something between a consultant and a software startup, what is your aim at the end? You want to be software? You want to be consulting?
So we see ourselves as a software company. Maybe I can talk a little bit about the team. So we have 4 people, 3 software developers, and then one guy, Max. He's mostly working on the administrative side of things. He could be considered, or he's considered our CFO. I'm the CEO. And so we are mostly working on improving the software, but I'm not sure if this is special to the semiconductor industry or this is the case for many other industries. For the customers, they see the benefit. And they would like to use our tool, but for them, it only makes sense to use the tool in production right away. But as explained earlier, of course, the time to market pressure is always there. So our aim is to start with projects now, show that the tool works. And that's basically how every EDA startup is working. They collect their success stories. And once they have a bag full of success stories, customers just buy because they know it works. The word is spread. Yeah, you have your recommendations on your website. You can go to conferences and people just know, okay, this stuff works. So the question, oh, do I mess up my production cycle or not, doesn't occur anymore. So our goal is that in 2 to 3 years, there will be no more consulting projects. Then we will only be focusing on sales and try to scale the business up. So long-term vision, maybe in 2027, so in about 5 years from the recording now, we aim to hit 25 million in revenue and 50 employees. So we're really going for a growth strategy here. We try to get now VC funding to grow fast, because also you have to know the market is really competitive, right? And there are some really big players in our market. I can just put up some names in case you want to check the stocks, because they're quite interesting. It's Cadence, Xilinx, Synopsys, and of course there's also Siemens. And now we have an advantage. We are ahead, but actually we want to keep the advantage and build on top of it. So, and I think with a classic bootstrapping strategy, that wouldn't work, because at some point the big companies would just throw money at the problem, would outbeat us. We want to grow fast now and keep our competitive advantage.
So currently you're looking something like a seed Series A investment?
Right now, I think we would be happy with a seed investment. And I think once we really have our success stories in our pocket and we can get rid of the consulting projects, then it would make sense to us to get a Series A funding with a good evaluation, have a really good, can really prove the product market fit. So there's no questions there. And get a seed Series A with a high evaluation and then scale it from there.
Sounds pretty good. Do you think Kaiserslautern, where you're located, you guys are actually the first startup we are interviewing from there, so they're a little bit under the radar. But that's a very good, very big technical university. Do you think it's a good place for a startup to start?
Well, we had this discussion as well. We were also thinking about maybe having a location in Dresden, in Sachsen, because there's a big semiconductor industry of Germany. But on the other hand side, since there's not that many startups in Kaiserslautern, but you have a lot of students, many students are from the region or the wider region, I think we have a good chance of keeping talent that doesn't want to go to Berlin, Munich or Dresden. It wants to stay close in the area, maybe Frankfurt, Heidelberg, Mannheim, Saarbrücken is a bigger city around. And I think we have a nice niche there. And also we have a good connection to university, since two of our team actually did their PhD at TU Kaiserslautern. So we have a good connections to the chairs where fresh students come in, fresh talents coming in. So I'm not worried too much about finding talent. And of course, if there's not that many startups, there is not that much competition for resources, right? Everyone is happy if there's a startup funding their business in Kaiserslautern. So we get really good support from all sides. And for us, I think it's smart to maybe stay in Kaiserslautern and use the benefit of the local.
Great. Awesome closing words. Only thing left for me to say, everybody who'd like to learn more, you can go down here in the show notes. There will be, as I said in the beginning, a link to your LinkedIn profile, a link to your company website, as well as all the social media channels you provide to us. So thank you very much. It was a pleasure having you here as a guest, Tobias, and best of luck for LUBIS EDA or LUBIS EDA. What's the right pronunciation?
EDA comes from electronic design automation. So we usually go with EDA, but I think everybody's saying it differently. So LUBIS EDA is also fine. If you type it into Google, some ways, I think we are always ranked 1. So whatever you do, you will find us. LUBIS EDA is the name.
Great. Thank you very much. Best of luck with the startup, and I hope to talk to you soon after successful fundraising.
Yeah, thank you very much. Thanks for the invite. It was a pleasure.
Thank you. Bye-bye.
Bye.
That's all, folks. Find more news, streams, events, and interviews at www.startuprad.io. Remember, sharing is caring.